Hi everyone. So in this video, I'm going to work on some of the homework questions. And here we're going to remind ourselves of the definitions that are given up at the top here. 1 mole is our quantity in chemistry, and that's going to be equal to 6.02 times 10 to the 23rd molecules. That's if it's a compound, like CH4 is a compound. There's more than one element connected together chemically. We would use the word atoms here if we had an element. For example, if carbon was just by itself, that's an element. So we would say 6.02 times 10 to the 23 atoms would be in 1 mole of just carbon. Okay, so knowing the terms for what type of substance you're working with is necessary. Now, what's this? 22.4 liters. So that's going to refer to gases. We would be asked about the volume of a gas. And we actually see that here in problem 2. So I'll be doing that one in just a minute. And then it says at STP. STP is standard temperature and pressure. And so that's a set of conditions that are defined as a temperature of 0 degrees Celsius or 273 Kelvin. The pressure is 1 atmosphere. Okay. Another way for pressure to be expressed is 760 millimeters mercury. Okay. All right. So now that we have those definitions, it's going to say at STP. So we don't need to know these right now, but it's helpful just to point them out. Okay, so let's do number 1 here. We have calculate the mass of 1.58 moles of CH4, and it tells us the molar mass of CH4 is 16.0 grams per mole. So we don't have to calculate that off to the side. The question gave it to us. And so off to the side here, they wrote down what was given. And I'm guessing what D is what to determine is what the D stands for. So we're looking for grams of CH4. So we have moles CH4, what's given. We're always going to start with what's given. That's written here first. And this is just a different setup, a different style of how to write these problems out. It's like we've took 2 fractions and just squished them together into one big space. So this is multiplication right here where they intersect. So if we treat these as 2 separate fractions, it's the same way that I did in the practice before. So we need moles to cancel. That's the whole point of this exercise. So I'm going to write mole CH4 down here. And so that way, when they're across from each other, those are going to go away. I get rid of that unit. Now, what do I want? I want grams. Oh, let's review the mole map. Okay, so the mole map is I can go from grams to moles or moles to grams in one step. I can go from moles to molecules or atoms, and atoms and molecules back to moles in one step. I can't go from grams to molecules or grams to atoms in one step. I have to go through the mole. Well, here we're just dealing with moles to grams. So consulting our map, it's just going to be one step. So I need grams up here. Now look at this unit. It says grams per, it's understood to be 1 mole. So we have 16.0 grams, that would go here. And it's per 1 mole. Now that we have the unit we want, which is grams, on top, the other unit that was given has been canceled out. Now I just have to do the math. And so when these are next to each other, we're going to multiply these two. We could refer to them as numerators using the math terminology. So 1.58 times 16. Okay, so I don't know if you could see this on the screen that well because it's angled. Okay. All right, so I got 25.28. Now, sig figs, right? We multiplied, so that's number of sig figs. I have 1, 2, 3, 1, 2, 3, so I should keep 3 in my answer, but I have 4 here. So that 8 is going to go away and round my 2 up to a 3. So let's rewrite that. 25.3, and my unit is just grams. Grams CH4. So that would be my answer. Okay, let's try number 2. So number 2 has this STP and they want volume. So we're going to use that other definition of a mole. What volume will 7.29 moles of CO2 gas occupy at standard temperature and pressure? Okay, so we're starting with what's given again. They've already placed it here for us. Okay, remember this is our multiply for our two fractions. Now I need to cancel moles of CO2 out. So I'm going to write that first across from it here in the denominator. Okay, and then they want me to go to liters. Now up in our mole map, we can go directly from moles to liters. Okay, it's all given up here. 1 mole is equal to that. So I'm going to say 1 mole is equal to 22.4 liters CO2. And so that's a definition for any gas, how much volume it takes up if you have a 1 mole quantity of that molecule or atom. So it's always going to be 22.4 for a gas per 1 mole. So this is set. Okay, so now all I need to do is cross out my unit that's going to cancel out. Here we have the mole canceling out. And then I just need to do my math with those numerators again. So get my calculator out. And so I have 7.29 times 22.4. And I get 163.296. Okay, let's check sig figs here. I have 1, 2, 3, 1, 2, 3. Well, this is a definition actually, so we actually wouldn't count that, but here we would. So we have 3, so I should keep 3. And so 163, so we'll say 163 liters CO2. Okay, and so that's that problem. Okay, the next one, my paper's a little cut off here. Let's see if I have some underneath here. Okay, how many molecules are there in 0.00583 mole sample of water? Okay, so again, we're going to start with what's given. I need moles to cancel out, so I'm going to write moles down here. H2O, it's going to be 1, and it's going to be the molar mass. Actually, no, we want molecules. So for this one, I'm going to use this definition here. 6.02 times 10 to the 23rd molecules. All right, so, all right, of water. Okay, and so now what I need to do is just multiply these. Now, remember in class I said it was easier to multiply just the front number here in the calculator for Avogadro's number. And then we'll deal with the times 10 to the 23rd after. So let's get the calculator out again. Okay, and so I'm going to do 0.00583 times 6.02. And I'm going to get 0.0351, we'll say. Okay, and so how many sig figs do I have here? These are leading zeros, so I only have 3 significant figures here, the 5, the 8, and the 3. And so in my value here, that's a leading 0. So my sig figs here would be 3, 5, and the 0, but that 9 would round it up, so it would be 0.0351. Now, don't forget that times 10 to the 23rd. If you leave your number like this, it's wrong. Okay, so we have this. Now, this is not the proper way to write scientific notation. The way we write scientific notation is the way it's written over here. We have one digit in front of the decimal point, and that digit is a number between 1 and 9. It has to be a single digit. Okay, and then we have the exponent. Okay, so I need to move this decimal point. It's in the wrong spot. It needs to be here between the 3 and the 5, because that would mean my first digit is a number between 1 and 9. So how do I get there? I would need to go 1, 2 spots to get there. Okay, 2 spots to get there, and I went to the right. So this would be then to the 21st power. I would subtract 2. So I get 3.51 times 10 to the 21st. And this would be molecules of water. Okay, let's take a look at another page here. This one. All right. So this is in the same assignment, and this is where we're going multiple steps. So let's take a look here what we have. How many molecules are in a 0.25 gram sample of water? And they gave us the molar mass. It's nice when they do that. Saves us a little bit of time. Okay, and so here they didn't put anything out for us to start. So again, we want to write what's given. So we're given 0.250 grams of water, okay, and they want us to find molecules. Okay, now we're going to start with what's given. Okay, I need that to cancel. So I'm immediately going to put grams of water across from it in that next fraction. Before I write any other numbers, I'm going to write that across because I know that needs to cancel. And the only way for me to go to molecules is through the mole. So there has to be moles up here. Okay, and then I can check and say, okay, the grams would cancel out. I'd have moles. I'm not asked for moles, I'm asked for molecules. So I have to do one more step. I have moles, I need it to cancel out. So it needs to be written across from it. And then up here I can do molecules. There we go. All right, now I can fill in my numbers. And this is just a suggestion for you to write the words out first, where they need to go, and then put the numbers in versus doing the numbers as you go. You have a higher chance of, perhaps writing the wrong number in the wrong spot. Okay, so now you can go back and think, okay, it's per 1 mole, how many grams? 18, they gave it to us. There we go. And then over here, this is a definition. It's 1 mole again. And what's the molecule number? 6.02 times 10 to the 23rd. Okay, moles will cancel. I'm left with molecules. That's what I was asked for. So I just need to do the math. So what we're going to do is we're going to take just what's in the front here and multiply those. We're going to do the division of 18. Let's see. So we've got here 0.250 times 6.02. Okay, and so I'm just going to write that over here off to the side. So I get 1.5. That would be 3 sig figs, so that 5 here would have to round the 0 up to a 1, times 10 to the 23rd divided by 18. Okay. I divide that by 18, I get 0.0836, and the rest are ones, so that won't do anything to the 6. All right, and again, okay, times 10 to the 23rd. Well, this isn't scientific notation either. I need to move this over twice, like the last problem, to get it written properly. So I'm going to write it again. 36 times 10, and I had an original smaller number. So my times 10 needs to express a smaller number. So this gets reduced to 21 because I moved 2 steps. Okay? Here we go. If I originally had a larger number and needed to move the decimal to the left, my 23 would go up. Sorry about that. So here's what I did again. So this number was not written in correct scientific notation. So I needed to move the decimal point so it was in between the 8 and the 3. That was 2 places I needed to move it. And because my original number here is small, it's much less than 0, my exponent for the 10 gets reduced by however many spots I moved. So I moved 2 spots. My exponent 23 gets brought down to a 21. If the number that I needed to change into scientific notation was larger than 1 at first, like say it was 83, and I had to move the decimal to the left, I need to express that it's actually a larger number in the exponent. And so in that case, going to the left to get the number in scientific notation, that 23 would have bumped up to a 24. So you just ask yourself each time, what was my original number? Was it large or small? And that'll help you adjust the exponent. So I get 8.36 times 10 to the 21. This is not my final answer. I need to add my unit. And there is our final answer. All right, I hope this was helpful and get those other problems worked. See you next time.